How's it going, YouTube? Right, let's do a bit of work on this camper again, shall we? Let's get the power on. So I think first thing we need to do is have a quick reminder of where we are and what we've got to do today. Right, in the last video, we wired all of this board up here. I've taken the inverter off again, just because it's lighter. The inverter's really heavy, so when I want to put this back in the back of the van, it makes it a lot easier with the inverter off it. So I've removed the inverter for now, and I've just put it up there. One thing I have changed a little bit since the last video is on the MPPT, we've now got a 16mm input coming in. So what I've done, if we have a look on the back of the board, you'll see the fuse holder there, and then this is the 16mm cable that's going out into the Orion on the input. So what I'm going to do is that 25mm cable that we ran out from the vehicle battery, I'll connect it into this side of the fuse here. This red cable with the little fuse on, that goes to this trickle charger here, so that'll charge up the vehicle battery when the power's in. And as you remember, we've got the high input going through the BMS on the ignition live, so this won't actually do the voltage sensing, and so it won't kick in when the charger's charging. This will only kick in when we've got an ignition live going to it. So I've done it that way, so that 25mm cable we can wire straight up into that fuse. That cable's here, we ran that in the last job yesterday. As you notice there, I've put disconnect battery. That's just a reminder for me, because I had to connect the battery back up so the central locking and the alarm could work on this camper, so I could close it all up at night. I just put a little reminder on there telling me to disconnect the battery again before I touch that. Right, so our first job today, this bird's nest of wiring here, we need to get all that wired up. So if we have a look here, what we've got, AC circuit wise, we've got two AC circuits. This one here is from the AC output 1 from the inverter. This has got the majority of fuses on it. Once I've got the wires tidied up, that will actually open. This has got the majority of the fuses on it, which is going to be for all the sockets and everything that are all around the vehicle. This one here, this is going to be from the AC output 2, and this will only ever become live when the hookup's plugged in. So this is all inverter and hookup, and this one is just hookup. What we're going to power off that is that double socket there. One of the things getting powered off that double socket is this Dometic box here, which will be a changeover for the fridge. So when we're on mains, it'll power the fridge off of the mains. And the other thing plugged into that plug there will be that 12-volt charger that we've just looked at for the vehicle battery. And then we've got a spare breaker for anything else that I decide to wire up to it later. Depending on the water heating I'm getting, what I might do is wire the water heater 240 up to that, so it works on 12-volt stroke diesel normally and 240-volt when we're plugged in. But I don't know, I'll make that up later when we get the water heater. What I'll do for now is I'll wire the water heater into this, and then we'll worry about it later. Next one along, we've got a little isolator there for the solar, because obviously when the solar is on the roof and it's out in the open, the two wires for the solar, the positive and negative, these ones here, they will always have power on. So to make those safe, we can wire them in there and bring them out to the MPPT. So if we ever need to work on the MPPT, we can isolate the solar there. Next two along there is we've got some fuse boxes. I've got two because I've probably got more things. I'm going to leave it exactly as that list that we did. This one here, so everything will be individually fused, and I'm going to mark up which ones they are. So what I'm going to probably do is I'll split these into two different loads. I'll figure out what we're going to do as we go along. Powering those, we've got a little Victron switch there. So from the Lynx distributor, we've got power coming out, going into there, out of there, and then it'll feed each one of these fuse boxes. And then the BMS can control whether that's turned on or off. So if the ACD contact is closed, the allow to discharge, then that will be okay and that will work. So as soon as the ACD opens, it'll turn the power off to that to stop the battery from discharging. What we can do if we want is have one of these on one side of it, and if there's any essential items, we can power them to the other side of it, so they'll always have power. You can do it that way if you want. What I'll probably do is just power both of these onto the output side of that switch. But if you've got anything that you really don't want to lose power to at any time, you can power that to the input side of the switch then, and one to the output. The next one along is we've got the Energy Solutions 4-way switch. This is the smart switch that they do. I'll get power to it, but all the outputs from it, we'll be wiring that up later, because we're going to do some posh things with that later on, because that gives us an extra page on the servo screen, and also we can log into this to turn it on and off and things like that. So we're going to use it for water discharging and things like that. Probably turning on heating jackets for the water tanks and all that sort of stuff. And then we've got the socket that we spoke about that will just be on hookup. Another thing that I need to do is that bus part there. I need to take a 50mm cable outside through that hole and connect that to the chassis to give us a chassis earth there that we can earth everything to. Right, so these cables, apart from the red ones, what we've got is the black ones are the 12-volt stuff and the blue ones are the 240-volt stuff. So what I need to do is I need to split these up, and I need to wire all the 240-volt stuff to the outputs of these MCBs there, and I need to get all the 12-volt stuff on these fuse holders here. What you've got is you've got the 12-volt input there, the earth there. So these are all the earthing bars at the bottom, so I can wire all the negatives up to there, and then the positives will go to each individual fuse output. Right, so what I'm probably going to do is I'm going to get a time lapse on, and let's get rid of all this bird's nest and wire it into here, and then we'll have a look again when it's done. Right, just thought I'd stop for a second and show you this. On the 240 side, look, what I've done is I've taken all the breakers out and everything so I can wire them all up. We've got a little bus bar all the way across there that joins each one of those breakers up. So what happens here on the RCD is your main live and neutral comes in there through the RCD, and then you've got a live and a neutral that comes out. The live goes into the bottom of the MCB, and then it's got a buzz bar that goes all the way along the bottom to join each one of those together. And then on the top, there are your outputs for your lives. Your neutrals all go into this neutral bar here. The best practice when you're wiring these up is the order that you're wiring in your lives there. Do the same order on your neutrals as well. So whatever's in this first one, put your neutral in this first one here. So if you've ever got to change the cable or any testing or anything like that, you know which neutral's which. So put these in the same order as these. Same with the earths as well. We've got a little common earth bar there. So I'll be wiring all the earths up into there, and then what I'll do is I'll take an earth out and then take it down to my ground bar down there. So that's how we're wiring up the 240 side of things. Right, so let's carry on and get this wired up. Right, that's the 240 volt side of things all wired up. So the one on the left is AC1, this is all coming from the inverter and everything. The one on the right is AC2, and that one will only work when it's plugged into a hookup lead or mains. What I've done is I've wired it up to that double socket there. What I'll do later is I'm going to wire this up to it, and then that is going to fit in the bottom down there somewhere. All these wires going through there that I've just thrown out of the way, they're all ones that are going to the Victron stuff. So you can see all the blue cables. We've got the AC input from the hookup lead, and AC out 1 and AC out 2. They'll all go back to the inverter. Right, so next job is all these black cables here. We've got to wire into those fuse boxes. So it's literally, the positive is going to the side of the fuses, and the negative is going to the earth bar at the bottom. And then that little one at the top, I've got to take that through to this contactor over here for this battery protection module. What I've done is I've just taken down a note of all the stuff that I've got to get power to, and I've allocated a fuse to them. I've kind of got the lights on this little fuse box and everything else on the big fuse box out of the way, just to try and separate it up. Another thing that I've done actually, up in this top corner over here, if you can see it, right up there, this is like a little temperature sensor that came with the inverter. I don't actually need that for the inverter because the BMS will monitor the battery temperature. In the original inverter kit, this is supposed to go on a terminal of the battery, but we don't need it. So what I've done is I've fitted it up there, and then the wire's coming out of here, and it'll go to the servo unit. Because the servo unit has got temperature inputs on it, so that'll go to the servo unit. And then what it'll do is these two fans here, I've wired those down there, and then they'll go to an output, a relay output on the servo unit, so it can start the fans up when this whole area gets too hot. That'll cool down the Victron stuff. What it's got there on the servo unit is we've got some temperature sensors there, look. And then on here we've got relay 1, relay 2, a common and a normally open. So what you do is we've got a fan there, positive, negative coming out. Negative will go straight down to an earth. Positive will go to the servo unit. This will come, say a 5 amp fuse. This will come from a fuse down there. This will wire up to the common, and this will wire up to the normally open connection on the servo. Just like there, look, you can see the common in the middle and the normally open. So what it does is when the servo is telling it to do something, it'll close this up and then make the circuit between the power and start the fan. So that's how we wire that up. Setting it up, we have to set it up through the servo software. We'll do that later. Right, so I'll set time-lapse up again. Let's get these 12 volt cables wired in. Once that's all wired in, we'll be ready then to start fitting all this Victron board in. And then we can wire up all the earths and everything else and get all this cables wired up. And then the very last thing is we'll be wiring up the battery bit here. Right, so back to the time-lapse. Right, and there we are. That's all the DC stuff wired up as well. What I'll do is once I've put the Victron front on and I've got a couple more wires to run in there, I can put the covers on then to cover up all that wiring, but everything's wired up now. I've even got the power coming out of that battery protect and going into each fuse box. What I did do while I was in here, is that termination block there for the Victron, for the CAN. I've taken it out of the BMS and I've put it in there, and then I've run that network cable down so I can plug that into the BMS. Down at the bottom, I've got that Dometic little transformer, and that's plugged in now up there for the 240, and it's got the 12 volts wired in as well, and then it's got an output that goes round to the back of the fridge. You'll notice down here as well, I've got this big earth cable in now. That's down through to the chassis. This is the earth for all this stuff. They're going onto this rail, and then I've got one more earth to come round from the Victron panel, and that'll go onto here as well. And that's everything then down to the chassis. Let's have a quick look underneath how I did that. Right, under the van, I'll not touch it because I've sprayed it all with this Hammerite wax oil stuff. But what I did was, where that big square bit is there, I drilled a hole through. Then I got a wire brush on it, took it back to metal, and I put a nut and bolt through and bolted it up. And then that gave me a post to bolt to. So then I've come through, I've got that black stuff on me, look now. And then I've come through with that conduit, and I've got a 50mm cable coming down on a lug, and then I've bolted it to that bolt, that stud. So that's nicely earthed to the chassis. And then what I've done is I've sealed up the top of the holes with some of that Puraflex stuff. And then I've sprayed the whole lot with that wax oil Hammerite stuff that I've got. I'll show you in a second. Right, so now I've shown you that, I can take these off of the ramps and put it back down on the floor. This is that stuff that I've sprayed it with. It's some underbody seal with wax oil by Hammerite. That's what I've sprayed the underneath with. I've got a couple of cans of that, so I might do some more bits later. Right, so next job is we've got to get this in the vehicle. I'm going to have a quick tidy up out there. I'm going to get this in. We've got these to take to the right place. We've got the high signal for the battery protect. I've got an ignition live there that we can join up to the ignition live that come from the front. And we've got the main power there that goes up to that battery protect. And then that's that side. Coming in, we've got a load of wires down there, which are things like the AC inputs and outputs, the solar input from the breaker, temperature sensor, the relay for the fan, and then the power from the battery that goes to the fuse on the back of the panel for this. And that's about all there is to wire up, to be honest. And then on this side, we've got the chassis earth, which will go to that block that I've just shown you. We've got the BMS cables there which go to the battery, and then the main cables there that go straight to the battery. And that's about it. So let's get this panel in and let's get it wired up and get to a point where we can actually turn on the power on this thing. Right, I'm going to tidy this up and get that in, and I'll check back once it's all wired up. Right, we're at a super exciting bit now. This is all wired up and it's ready to turn on. None of it's been on yet. It's off on the isolator. I've just connected the last connection now onto the battery. Put this torch back up so we can see. Everything's connected. I put up the inverter and connected all the AC circuits into that. So that is literally now ready for powering up. And I thought we'd do it here together. So let's set the camera back up here and let's turn it on together. And once we've verified that it actually works, I'll have a quick tidy up and then we'll turn on the solar breakers and things like that and have a look at it. But let's turn it on. We've got lights. and we have life. All the lights have come on in there now. That's looking good. Nothing's blown up, nothing's on fire. I'm going to have a quick tidy up and let's catch up again in a second. Right, it's a few days later. I've been playing around and I've got it all set up properly. To be honest, there's not that much setting up to do. Because this one has got the smart BMS, because we've got the VE Direct plugged in on those two, this inverter's on VE bus anyway, so they're all talking to each other through the servo, and what this does is this completely takes over all the charging. Normally on these Victron systems, once you get them all running, you've got to spend some time then with each individual piece of equipment. Using the Victron Connect app, you can go into each individual piece of equipment and change all the settings on it because they're all connected via Bluetooth, and set them up for the lithium batteries. You need to set all the voltages and everything like that for all the charging. But because, like I said, this one has got the smart BMS, this literally takes over everything and it turns the whole system into a plug and play system. The only thing you can't program as it comes via the Bluetooth is the Multiplus 2. To program those, there's two different ways. There's a few different ways of doing it. I've programmed this one, but what I've done is I've used the VE Configure app, and then I've connected online over the VRM. We'll have a look at that all in a minute. None of this equipment really I had to set up for the battery. It's all done it automatically. What I have done though is I have set these all up so they're all set up for the lithium batteries. So if anything ever happens to the communication cables on these, then it'll automatically switch over to the lithium settings. You don't really need to do it because if anything happens to the communication, you'll get an alarm anyway. But I've just done it because you can. You don't really need to do it. I've got a hookup cable outside. It's not plugged in at the minute, but it does work. When you plug it in, after about a minute, it turns on this charger here on the AC2 output, and it also switches over the fridge to the 240 volts from the 12 volts. I've also set up the temperature sensor that we fitted in the top, and I've set up the fan so that comes on at a certain temperature. So let's have a look inside at the servo display and just have a look at some of the things I've actually changed. Right, so if we have a look at the display, you can see how it's running now. We've got 290-ish watts of solar coming in. That's charging into the battery. The battery's sat at 87%. We've got 244 watts of DC power going out. That's because I've got literally all of the lights turned on at the minute inside. The AC loads, that's just ticking over at 18 watts, just because it's got a little bit of things in standby. What I have been doing is, if I don't want the inverter, then if I click on the display and we go into menu, we can go to the Multiplus 2 there. You can see it's inverting, and then if we just click on switch, and then we can change that to charger only, and then what it does is it removes that load there. So it's not using anything in standby. Because I've got things like the induction hob and things like that, there's probably just using a little bit of power just sat in standby. That I can turn that inverter off when I'm not actually using it. So if we go into a few of the menus and just see a few of the things that I did actually change, if we just pick one, Smart BMS, the only thing that I actually had to set up on this was in the settings, and that is the battery bank. And once you've set up the battery bank, it literally takes over all the charging and does everything all itself. So in the battery bank, you have to set your voltage of the system, set your capacity, which is 330 amp hour for hours, and then what you do is you put how many batteries is in the bank. We've got one obviously in this. I did that initially off of the Bluetooth from the phone on Victron Connect, and then from that point then the BMS literally just takes over everything. So all of the charging and everything else is just controlled by the BMS. The fan that I fitted, if we go into settings, right down at the bottom, you've got input output. So what I had to go into there was the analog inputs. We've got a temperature sensor. So what I did was I turned temperature input 1 on. That's the one we wired up. And then what that did is that turned on this one here, which I've renamed electrical cabinet. And then what you can do from that is then you can use it to trigger some relays. So then if we go back down into settings, down to relay, We connected the fans into relay 1. So what I've done is I've set that up as a temperature, because that's what it's doing, it's reading the temperature. And then you can go down into temperature control rules there, down below. It'll come up with the temperature sensors there, so we pick the electrical cabinet. So what we can say is at 40 degrees Celsius, it turns on the relay, and at 35 degrees, it turns it off. And then we set it, look, relay to relay 1. You can actually have condition 2, so it's got multiple stages, so it can trigger the other relay to do something else when it gets up to a different temperature. But I just wanted that to come on at 40 degrees. And if we go back out now, right up at the top, we've got the electrical cabinet. You can see there it's 29 degrees now in there now. I've tested that, and it does start and stop the fan exactly how I want it to be. So that's working perfect. The cabin temp there, that's working off this Ruvi temperature probe here. So all I did, there was a little plastic tab in there to start it up. You pull the plastic tab off, and then what we do is down here again in settings. Then we can go right down the bottom again to IOs, and what you'll see there is got Bluetooth sensors. And then what it did is it appeared straight away there as soon as I've pulled that tab. So then you can turn it on and then set it up. You can do the same, so it's triggering relays and things like that, just the same as the other one. But I've literally just left it as a temperature sensor, just so I can see the temperature there, because it shows up in the VRM quite a bit nicer than what it does there. Now, one more thing that I actually changed in the Multi+2 settings, I had to do that through VE Connect. What I can do is I can do a completely different video on programming the Multi+ if people want to see that. But what I did was, if we go back to the beginning, you see down there it's got the little fan and the sun symbol. What that means is it's set up for wind and solar priority. So if I plug the hookup lead in, let me plug it in now. That's plugged in now. It's not really doing a lot at the minute. Let me just go back to the settings. We'll turn this from charger only to full on. And what you'll see is it's doing absolutely nothing, even though it's plugged in. In a second, what it'll do is this AC loads will kick in. That'll be the AC2 kicking in to take over the fridge and the vehicle battery charger. The grid's kicked in a bit more now as it's drawing out for the fridge, and the charger as AC2's kicked in. But what this wind and solar priority mode means is it won't charge the battery straight away. What normally happens is when you plug the AC in, that'll ramp up to say a few thousand watts, and then it'll be charging this at full power to get this up to a full charge. But using this wind and solar priority mode, what it does is it carries on using the solar. Look, normally this would go down to 0 and it'd be charging off of the charger. But we don't want it to do that. We want it to use the sun while ever the sun's there. So what it does is it charges off of this and not this. If it doesn't reach a full charge within 7 days, what this will then do is this will take over and give the battery a full charge. Or if this gets too low, then this will kick in and give this a full charge as well. But this is really good, because then you're not using the mains power when you don't need to. You're using the sun, which is free. You want to be using that, don't you? And just to prove it, what it'll do is if I use AC loads in the van now, what it'll do is it'll take the AC loads from the grid, but carry on charging the battery from the sun. So if I pull back a little bit, what we see there is I've got a little kettle set up. So if I start that boiling, this is only one of those little travel kettles. I bought that one because it's physically quite small, but it is quite low powered, and it is kind of annoying because it takes a while. So I might actually swap that for a full size one at some point. Hopefully you can hear me above the kettle. But what you can see now is we're drawing 800 watts out of it, and it's bringing 800 watts in, and the battery is still being charged. You can see the lines going across. Look, from the solar we've got 304 watts of solar coming in, so the AC is just going straight across. And I think that's really good, because if you're parked anywhere, especially somewhere that's on a meter, what that'll do is that'll use the sun when it's available. But this one, this setting here, let me just stop that. But this setting here, the wind and solar, you have to turn that on inside the Multiplus settings. You can't do it from here. You have to log into the Multiplus to do that. And on the phone, there's a few ways of connecting. You've got your Victron Connect, which gives a Bluetooth to everything. You can see now, look, this is that charger for the vehicle battery. That's turned on now. That's charging the vehicle battery up, and that's because we're on hookup lead. It's kicked in that AC2. But if we go to VRM at the top there, there's my setup there. We can click on that, and then we can connect to it the online portal. And then there you can see, this is what you can see from anywhere. While ever there's internet on this van, you can log into this remotely from anywhere, and you can see what the van's actually doing. And through this, there's lots of other things you can actually do as well. I can do some more videos on this and talk about it more in detail if that's what people want. But for now, this is just a quick overview of what a few things I've had to change and set up. One good thing about this actually is in the top left, if you go to device list and then right down at the bottom, it's got firmware update there, look. One of the pieces of firmware that you cannot update via your phone normally is the Multiplus. You normally have to plug in to do that. But with this, doing it this way, you can actually do it remotely. So if you click that just to check, it's just checking all the devices now to see what firmware version they're on. And then there you can see, look, they're all up to date. The only one that isn't is that one, which is the Energy Solutions Smart Switch. That's not on the Victron website. So they've not got a firmware for that, but everything else is now up to date. And I did notice when I first did this that the Multiplus 2 was out of date. The Multiplus 2 was out of date because you could not update the firmware any other way. And then once I'd done this, that updated that. But everything's powered up just as it should be. We've got the induction hob now. This is all working. I'll get some pans for this. I've not got any proper pans for this at the minute. I need to get some so I can properly test this out. Right, I found one of these camping kettle things. So what we can do is we can try that out in a second. What I've also done, I've unplugged the hookup lead. So we're just running on inverter. So let's see how this performs. So if we turn that one on, turn it up to 9, and let's see what it does. We can see there, the power's ramping up. That's 1.3 kilowatt now. What we might do actually is let's put it on that back one because I think that one is the more powerful one. So let's turn that one off, turn the back one on, and let's put it on there and see what it does. We can see the power's ramping up on that one now. That's 1.7 kilowatt, which is about right because I think this is just under 3 kilowatt. I think it's 2.7 kilowatt for both of these running at the same time. So looking at this is if I start this as well, let's start the kettle and let's really give it some. We're now running at 2.3 kilowatt. Battery's going down as you'd expect. We're getting 300 watts of power from the solar as well going into this. But that is working perfectly fine. There's no lights dimming or anything like that. Everything's coping with it perfectly fine with the look of that. That's starting to go. Right, another thing with this smart BMS that's a really good little feature is what it'll do is it'll redivert power from various things. So once this battery gets to 100% and this is fully charged, what it'll do is the solar, if there's any solar energy, it'll redirect those straight to the DC power, and whatever this is drawing, then this is what the solar will produce. So it kind of balances it out. So this sits in an idle state, so it's not charging or discharging the battery, it sits idle, and then all the DC things are powered directly from the solar then. It's not producing too much and it's not producing too little. And it's the same with the other things. So if the inverter's on and it's pulling a few watts out of there, it'll get that power from here and it'll distribute the power to where it needs to be, but not putting it in the battery, so not to overcharge the battery, and it keeps that in an idle state. A really clever little thing that these BMSs do. One more thing to show you with this wind and solar priority, if I plug the hookup back in there again, there we are, we can see the grid power's back on again now. If at any time we're thinking, well, I've only got 85% battery, but I need a full charge because I'm going away soon, and because we're on this solar and wind priority, it's not actually charging the battery. There is an override for this. If we go into the menu, what we can do is we go into multi-plus there, and then it's got to charge the battery to 100%. Press to start. So if I press that, there you are, look, shore power will be used to completely fully charge the battery for one time. After the charging process is complete, the system will return to normal operation, prioritizing solar and wind energy. Do you want to continue? Let's put yes, and that'll be charging then from the grid power. So what we'll see is this start ramping up, and then it'll start putting all the power into this battery to get a full charge in it. And you can see that this has gone orange at the side because it's overridden and it's gone into a charging state straight from the grid. You'll notice we're pulling 2000 watts out of this. We can actually get more out of it. This is limited at the minute because of how I've got it plugged into the garage, but what you can do is you can actually change that current limit. You can do it off your phone really easy as well. But down here, look, we've got AC current limit 10 amp. And then what we can do is we can change that up or down depending on how you've got it plugged in, because obviously some of these hookup leads on the blue plug, that's a 16 amp, but I've got this plugged in on a 3-pin plug, and I've got other stuff plugged in as well, so I don't want to overload it too much, so I've left it on 10 amp, which is really good, so you can limit the current that's coming into the vehicle. So that's a super quick overview of this vehicle on that panel, and a few other things I've had to change. Whilst we're talking about the lighting as well, on the back of the bathroom wall here for the bedroom, we've got switches. These switches turn off all the individual lights, but what I've made it do is these lights at the front of the vehicle, as in those orange ones there, which will be for the ambient lighting, and these white ones for the roof that go all the way along. What I've made it is I've made those two sets two-way to the back. So what I can do is down here, look, there's a switch because there's going to be a panel here, and I'm going to fit that switch into this panel. So what we've got is on this switch, we can turn that one on and off, we can turn that one on and off, which is the front of the vehicle, and then the rear of the vehicle is powered from down at that end of the vehicle. But what you can also do is, because it's two-way, is on these switches down here, is when we're going to bed, we can turn everything off from down here, just like that. And that's two-way lighting. So for anybody that wants to know how to do that, it's quite a simple thing to do. It's done in houses, at the top or bottom stairs and hallways and things like that. But what we can do is, let me show you quickly how I've wired that up to make the lights two-way. Right, so normal one-way lighting, what we've got is we've got a plus and a minus coming in on our power. We've got a light there with a plus and a minus coming from the light. And then just here, we've got a switch. And then the negatives, they join together. So then all you've got is you're switching on and off with your switch on the wall to turn it on and off. Two-way lighting, you've got two sets of switches. So instead of having a switch with 2 poles, you need a switch with 3 poles. So what you have is you have a common, and let's say a normally closed and a normally open. And then at the other end, you'll have another switch with a common, a normally closed and a normally open, say. Let me just move this slightly. And then what we've got over here is we've got a light with a positive and a negative. And then here, let's bring our power in down here. We've got a positive and a negative there. This space in between the 2 switches, this could be at the front of the vehicle, say, and this could be at the back of the vehicle. So what you need to do is you need to connect the positive to the common of the first switch. And then between the 2 switches, you can run out a 3-core cable. So 2 cores connect between the 2 normally open and normally closes. And then the 3rd core can connect straight through for the negative there. So then what we do is the negative from the light we take to that negative, and the common from the second switch we take up to this positive on the lamp there, just like that. So if I just put a dotted line through there, this is one switch, this is the second switch, and you've got a 3-core cable going between the two switches. So as it is now, you can see that'll turn this light on. If you switch this switch, that one will move over there, and then the power will go through that switch to there, and then it'll go nowhere, so it's switched off. But if you want to switch it on, you can go to the other end and then switch it, and then that will switch that, and then the power will come out there. And then what you can do is go to that end, switch it again, and then that will break that circuit and make it so you can turn it on or off from either end, if that makes sense. So that is how you do a really simple two-way lighting circuit in a camper van, just by using a 3-core cable between the two switches. So I hope that's helped somebody that wants to do that in their vehicle. It's a really simple thing to do. Right, so if there's anything else specific that anybody wants to know about the electrical system or anything like that, comment down below. What I'll do is I'll try to do some videos on it in a lot more detail. What I will do anyways, after the build is finished, I'm going to go back and I'm going to start going through other components in the van and going through them in a lot more detail. What I'm going to do in a minute, there's a new Victron GUI coming out soon. There's a beta release for it, so I'm going to update it to that in a second just to have a look at it. I've been waiting to finish this bit of a video before I change how the whole thing looks. So we can talk about that later. So if there's anything specific anybody wants to know a lot more detail, comment down below. If I get enough comments on the same subject, then I'll definitely do a video straight away. Other than that, I'll probably wait till after the build, like I've just said. I hope it wasn't too boring, because I know we've got quite a lot in over the last 2 videos with the electrical system. There is still a few cables that I've missed out. I mean, there's one for the 12-volt toilet. Because I'm having like composting toilet, they have like a little fan in it. So I need to run out of cable for that. As you can see now, I have got a little toilet in there. That's the one out the Volkswagen camper, because I've just put a toilet in. As you can see, I've got the bed in as well. The reason for that is I've just had a couple of nights here and there just in it on the drive, mainly because I want to get the cats used to the camper. One of the reasons for building this bigger camper is so we can go on longer holidays further away and take the cats with us as well. And the cat has got its own adventure channel, which I'll probably talk about later. It's not very adventurous at the minute because we're on the drive. We've got a lot more still to do on this, so don't forget to subscribe if you want to see this. Click the little bell icon so you can be notified on the next videos. I have got some other videos to do in between the camper build as well, so some tech reviews and things like that, so I'll be sticking those in between these videos. Like the video if you liked it. I hope you're all along for the ride, and I'll catch you again in another video. Cheers.